Welcome to my page. Today we are going to look at logarithm with table. We have question 1 to 4, and as you can see, I am here with mathematical tables so that we can look up the logarithm and the anti-logarithm value from the table. So we have question 1 to question 4. Let's attend to them straight away. Yes, when you are solving logarithm, number 1, you need to know how to convert number to standard form. Like here is number and here is your log. So like 75.6 and 85.04. How do we look up the logarithm of this number from the table? How? For example, let me write it boldly here. We have 75.6. So first of all, you have this, you say log 70 under 5, then difference 6, difference 6. You have log 70 under 5, difference 6. That is how to look up the logarithm from the table. So let me open it and show you. This is the logarithm table. This x is the number, which is that first 2. Log 70, you check from here, starting from 10 till you get to the number up to 99. You come to the second side of here, we still have 55, 56, up to 99. So, but from 0 to 9 is the under I am referring to. The under, I'm saying 70 under 5 is this. From 0 to 9 is the under. Then you now see the difference by this side. See the difference from 1 to 9. So that is how to check up the logarithm from the table. As we have it here, let me show you how to check this one. When you check, this is 55. Let me bring one rough. I have rough here. You see, you look at it. Where is 70? This is 70. So when you have your 70 now, you check, this is 0. From here, you have 0, 1, 2, 3, 4, 5. That is 85, 84, 82. Here. Then difference what? Difference 6. You come to this side, you count 1, 2, 3, 4, 5, 6. You even see it on top. Difference 6 is 4. So note that you are going to add the difference to the logarithm. You add. You're going to add it. So as you are adding, you have 2 plus this 6, 8, 4, and 8. But point. So you go to your main book and write it clearly. Let's write it clearly. So we have, but first of all, we need to convert this one to standard form, like I told you. This one, you have to move it 1, 2. That 2 you must write. This 2 is called the integer part of the logarithm. The 2 is the what? Integer part of the logarithm. So you have checked for log 70 under 5. 70 under 5 is this. Then difference 6 is 4. And I said earlier that you have to add it to the logarithm, which is 84, 86. So, and in logarithm, you have the two parts. The two parts. Okay, I will explain that later. So this is the second number, part of this number one question. Question number one. The second number is 85.04. So you have to convert it to standard form. How many times are you going to move this point? Once. So you put 1. So we are going to look for this 85.04. It's still the same thing. You pair the two number log 85 under 0, then difference what? 4. 80 what? 85 under 0 is what? This is 85. You come here, saying 85. This is 85 under 0 is this. 85 under 0 is 92, 94. Difference what? Difference 4. You go straight on this line to where you have the difference column. 1, 2, 3, 4. Difference 4 is 2. You also add 4 plus 2, you have 6, 9, 2, 9. So we have checked so you go and write it. You write it down. You have your 9, 2, 9, 6. It's as easy as ABC. So you add it. Because it is multiplication, you are going to add. Because of this multiplication sign, in indices, when we have multiplication, it changes to what? Addition. In logarithm, with that table, when we have multiplication, it changes to what? Plus. Also, with table, it's also going to change to addition. So 6 plus 6 is 12, carry 1. 8 plus 9 is 17 plus 1, 18. 4 plus this is 6. 8 plus 9, 17. Carry 1. 2 plus 1 you carry, you have 4. So this one is what we are going to look for, the antilog. Well, we have antilog table, we also have a logarithm table. So you must note that when you find the log, you must not stop there, you go straight and look for the antilog. Like this number now, we have two parts. This 4.7682. We have two parts. Remember, we carried one from here. We did not put 7. 7. So we have two parts. This is the integer part that I say I will tell you, integer, and this is the decimal part, which is the fractional part. You have the integer and the decimal parts. You can call this one the mantissa. This one, the characteristics. Whatever. But that is not why I'm saying this. So just know that this is the integer part, this is the decimal part, or the fractional part, or the mantissa. So, but in looking for the antilog from the table, this one you are not going to include it. The integer part is not included in looking for the antilog. What you need to do is to find the antilog of 77 under 8 difference 2. Antilog of what? 77 under 8 difference 2. So, and when you check your your mathematical table, you also open to the next one, you see anti-logarithm table. You can see it, anti-logarithm of numbers is the table I'm talking about. So you look for 77 this 77 under 8. You still follow the same style of logarithm. 77 under 8 is 5998. Difference 2 is 3. Difference 2 is 3. Okay, so you add it. 8 plus 3 is 11. 10 carry 1, 10 and 6. So what you write, know this point, you write 0 point. This one is point 0.6001 times 10 raised to the power of the integer part. Don't forget 4 plus 1. You must add 1 to the logarithm, the integer, each time you look for the antilog. Note that you must add 1 because logarithm of a number, as you are, is given, but we are going to look for the number, a kind of a reverse form. The antilog of a number is the reverse of logarithm. That is what I mean. So you must add 1 to cancel that revision of the logarithm. So we now have 0.6001 times 10 raised to the power of 5. So what do? We count how many times? 5 times. 1, 2, 3, 4, 5. It's equals to 60010. That is the answer. It's as simple as ABCD. In any way, you can go to anywhere and solve it. You still get the same solution. So number 2, which is 43.14 times 10 raised to times divide by is divide, not times. Divide 8.932. So we do the same thing. You roll your number, your log, and your number here. So the first one is 43.14. How many times are you going to move this point? You must know how to solve standard form, how to convert a given number to standard form. You move it once to come between the first number and the second one. This point, you must move it between the first and the second number, not in real time, but that is what you have to do to find the integer part, which is 1. It's once, if you have to convert this to standard form, you have 4.314 times 10 raised to the power of 1. You get it? 4.314 times 10 raised to the power of 1. This 1 is what we are writing here as the integer parts. So what next do? We look for 43 under 1, a logarithm. You have to look for logarithm first. Under 1, difference 4. 43 under 1 will give you 6, 3, 4, 5. 6, 3, 4, 5. Logarithm of what? 43 under 1 is what? 6, 3, 4, 5. Difference 4. Difference 4 is still 4. So you have this, which is, you have to add, like I told you. 5 plus this, you have 9, 4, 3, and 6. So you have 6, 3, 4, what? 6, 3, 4, 9. So the second number is 8.932. So how many times are you going to move this one? 0. You're not moving it anywhere. It's already there. Okay? So you move it nowhere. 0. So what we need to do is to look for the logarithm of 89 under 3 difference 2. Logarithm of 89 under 3 difference 2. So let's check 89. 89 under 3 is 959509. Difference what? Difference 2. Difference 2 is 1. You add it. This plus this 0, 0, 5, 5 and what? 9. So you have what? 95, 0.95, 00. Because this one is division, you're going to minus. You're going to subtract. Note in your logarithm law or in this indices law, when you have division, the power is going to change to minus. So that is exactly what we are doing here. This thing we are looking is the power. 10 raised to power of logarithm of any number is 10 power something, 10 power something. This is the power we are writing. So let's subtract 9 minus 0, 9, 4 minus 0, 0, 3 minus 5 cannot. Carry 1 from 6, add it to 3, 13, 13 minus 5, 8. This one is remaining what? 5. 5 minus 9 cannot. Carry 1 from here, put it 15. 15 minus 9, we have 6. This one is left with 0. 0 minus 0 is what? 0. So look for the antilog of this. Antilog of this. So what antilog are we going to look at? 68 under 0, difference 9. 68 under 0, difference 9. So you open your antilogarithm table, you go to 68 under 0. 68 under 0 is 4797. Difference what? 9. Difference 9 is 10. So you add 0, means 7. 7 plus 0 is 7. 9 plus 1, 0. Carry 1, 8, and 4. So that is what you have. But what you are going to write is 0.0. You have 0.48807 times 10 raised to the power of this integer part, which is 0 plus 1. You must add 1 to the integer part of all the antilog you are going to look for. So we have 0.487 times 10 raised to the power of 1. So that means you are going to move this point to the front once. Okay? So we have 4.807 as the answer. You understand? As the answer. It's very simple, no issue. So let's do number 3. Number 3. This number 3. Number 3 is 0.0547 multiplied by 0.4334399. 0.0547 times 0.4399. So let's look for the log. We have the number and the logarithm. So we have 0.0547 and 0.4399. So what we do here, we convert this one to standard form to get the power of the 10. So what we move this point to the in between the first two number. 1, 2. How many? 2 times. 1, 2. So we have, instead of, because we have been moving this one back, we move this one back. That is why it's positive 1. But if you are moving from back to the front, it's going to carry negative sign. So because this one is going from back to front, we have negative 2, which is represented as bar 2. Bar 2 point. Do you get it? Bar 2 point. So even this one, 0.4399, you are moving it once, it will change to bar 1 point. Bar 1 point. So we are going to look for logarithm of 54 under 7. 54 under 7. 54 under 7 is 7380. No difference. Okay. So, and here we have 43 under 9. 43 under 9 is 6425. Difference 9. 63 under 9, difference what? 9. The difference is what? Is 9. So we have 5 plus, we must add them. 5 plus 9, we have 14. Carry 1 here, 3, 4, and 6. So you have 6, 4, 3, 4. Because it is times, we're going to add. We're going to what? Add, addition. You add it. So this plus this is what? Is 4. 8 plus 3, 11. Carry 1. Add this here, 4. 4 plus 4, we have 8. This is what? This is 6. 7 plus 6 is what? 13. Carry 1. Like this part. You know, this bar 2 is minus 2. Plus minus 1. Then this one we are carrying, we are going to add to it, which is plus 1. Don't be confused. This is bar 2 minus 2 plus bar 1 minus 1. Then the 1 that is left that we carry from this 13. 7 plus 6 is 13. Carry 1, put here. Okay? Put it into this place. So we have minus 2 minus 1 plus 1. We have minus 3 plus 1 is equals to minus 2. So here we have bar 2. So bar 2, we look for the antilog here. We look for the antilog. So let's do it quickly. The antilog of 38 under 1, difference 4. The antilog of 38 under 1, difference. So 38 under 1 is 2404. Then difference 4 is 2. So we add it. We have 4 plus 2, 6, 0, 2, 4, 2. So we write, make sure you add 0. Now 0.2406 times 10 raised to the power of bar 2, which is minus 2 plus 1. You must add 1. Don't forget that. You must add 1. So we have 0.2406 times 10 raised to the power of minus 2 plus 1 is minus 1. So because it's negative, we are going to move this point backward 1 time. So we have 0.02406 as the answer. Very simple. Don't be confused. Follow it step by step, and you will get it. Let's do the remaining one, which is number 4. Number 4. I'm going to do it very fast. We have 0.0824 divided by 0.009627. So draw the line, the number, and the log. We have 0.0824 and 0.009627. So let's find the integer part. The first one, how many times are we going to move the point to between the first two numbers? 1, 2, which is part 2 point. This one, how many times? 1, 2, 3. We have bar 3 point. So this one, we're going to look for logarithm of 82 under 4. 82 under 4 is 91, 91, 5, 9, 5, 9. So that is it. Okay. So this one, we're going to look for 96 under 2, difference 7. Logarithm of what? 96 under 2, difference 7. So you go to 96 under 2, you have 98, 32. 98, 32. 98, 32. So difference what? Difference 7. The difference 7 is 3. You add 3 and plus. This plus this 5, 3, 8, and 9. So you have 9, 8, 3, 5. Okay. So because it is division, we are going to subtract. We're going to subtract. So 9 minus 5, we have 4. 5 minus 3, we have 2. 1 minus 8 cannot. Carry 1 from here and put to be 11. 11 minus 8, we have 3. Mind you, this one is remaining 8. Take 1 from here. Note this particular place. Take 1 from minus 2. It will be 18. 18 minus 9, we have 9. Already, we have 2 minus 2, and we took 1 from 8. So what is there now will be what? Minus 3. Do you understand? We took 1 from this place, bar 2, which is minus 2. So minus 2 minus 1 is minus 3. So here is minus 3 minus minus 3. Minus 3 minus, because of this division, then bar 3. So we have minus 3 plus 3. Minus minus plus. Minus 3 plus 3 is 0. So we have 0 here. So this is the number we're going to look for the antilog. Okay. Antilog of what? 93 under 2 difference 4. So let's look for 93. 93 under 2 is 85, 85, 51. Difference 4 is 8. So we have 9, 5, 5, and 8. So we have 0.8559 times 10 raised to the power of 0 plus 1. Okay, that's what we have. So we have 0.8559 times 10 raised to the power of 1. Because we have 1, the power of 10 is 1, we are going to move the point 1 time. So we have 8.559 as the answer. Very simple. So I believe if you follow it step by step, you will get it. And if you have any question, just drop it at the comment section and we'll attend to it. So see you in the next